So let's start. Lesson 2, average speed and acceleration. And what we're going to try and do is start out with something that we know and understand and see if we can build that into a better understanding of the universe. In Science 10, you learned that speed is distance traveled in a unit of time. In Science 10, you learn this. Now, don't write this down yet, please. Don't write this down. You learn speed equals, don't write this down, distance over time. First of all, we're not going to use the letter S for speed. I think they use S in Science 10, or do they use V for velocity in Science 10? We're going to use V for velocity in Science 10. So you can write down V equals D over T. V equals D over T. Distance divided by time. What's the speed on the Lougheed? What's the speed on the Lougheed when you're heading out of Pitt Meadows towards the Pitt Bridge? 80 what? It's not 80 kilometers, that's distance. 80 what? What are the units? Kilometers per, don't write this down, hour. Can you see, Oscar, distance over time is actually contained in the units. The formula, if you know how we measure speed, the equation is sort of built in there. Now, kilometers per hour is the speed that we use on roads. The speed that we're going to use in physics is meters per second. Most of the time, we'll do conversions from kilometers per hour to meters. In fact, you know what, Thomas? 90% of the time, I'll give you the numbers in meters per second. And what we're also going to do is we're going to learn a shortcut for going from kilometers per hour to meters per second and vice versa. Colin, how many different letters do you see in this equation? How many variables? Turns out there's actually 3 different equations there. Another way that I could write this is you can write this down. I could get the D by itself. Now, how would I get the D by itself? What's the T doing to the D mathematically, Colin, my friend? Is it adding, subtracting, multiplying, or dividing? What's the opposite of dividing? How would I move the T over to the other side? So another equation that comes out of here is that one there. Turns out distance, as long as you're not accelerating, is speed times time. In fact, you know what? We're going to add a little subscript. Next to the V, add a little AVG. Distance is average speed times time. That will work, because if you're slowing down and speeding up, take the average and you're still okay. You're still okay. So I'm going to spread this out just so it doesn't look so clumped. I'm going to go V average times T. Hey, there's another equation I can get from here as well. I can actually solve for time. Looking at this one here, see the T? What other variable is on this side right here? What letter do you see? V. What's the V doing to the T mathematically? Adding, subtracting, multiplying, or dividing? Multiply. We don't write anything, it's multiplying. So how would I move the V over? What's the opposite of multiplying by V? Turns out another way to get time is distance divided by average velocity. These aren't all on your formula sheet because within about 2 weeks, what I just did there, you'll do in your head from this guy. Although I think on your formula sheet, I might have given you that one. I can't remember, but I only gave you one version. One of the things I'm going to try very hard to teach you, and I'm going to succeed, is what's called, Thomas, formula manipulation. I'm going to try and give you the ability to glance at an equation and rewrite it to get any variable by itself in your head. And I'm going to push that because it cuts down on your memorization by a huge amount. Huge amount. Let's keep going. So I said, average speed is total distance divided by time. Instantaneous speed is the speed of an object at a particular instant. So if I said to you, well, we'll talk about that. If an object moves along at the same speed over an extended period of time, we have a word for that. We call it uniform or constant speed. Uniform or constant mean unchanging. Jordan, cruise control if you're on the freeway and no traffic. Jordan, Justin, did it again. Cruise control if you're on the freeway, no traffic. Thank you. Apparently I had a long weekend too. Yeah, brain. Uniform speed is uncommon, but it is possible to achieve nearly uniform speed in some situations. Cruise control, I just said. Usually, however, a vehicle is making small changes in speed and direction all the time. Okay. What if you're not traveling in a straight line all the time? Well, then its direction becomes important and must be specified. When we have both, underline this word, magnitude and direction, we call the two properties, the speed and the direction, the velocity of an object. What's the speed on the low heat when you're heading out of town 80 kilometers per hour? What's the velocity? 80 kilometers per hour, 28 degrees north of east, or something like that. I'd need to find that from a compass, or I'll give it to you in the question. So if you say your car is moving 80 kilometers per hour, you're describing your car's speed. If you say your car is traveling at 80 kilometers per hour due north, you've just given me the velocity. Magnitude, 80. Direction, north. The difference between speed and velocity is going to be very important in situations where the direction changes. As a great example, look up. That right there. Part of the way we were on the way up, part of the way we were on the way down. So ball being thrown into the air, both its speed and its direction change. In fact, its speed is also changing. You may have noticed, Jordan, on the way up, it's slowing down. On the way down, it's speeding up. We'll be able to analyze that in about, all goes well, 3 weeks. We'll look at free fall and figure out all sorts of stuff. What?
Isn't there like a special number for that?
Maybe. Maybe. Acceleration. 9.8 if you're trying to figure that out, but that's the acceleration due to gravity or the Earth's gravitational field strength. Yeah. Whenever the velocity of an object changes, the object experiences an acceleration. In fact, acceleration, Alexa, is defined as a change in velocity divided by a change in time. Put an equal sign there. We have a symbol for the word change in. Anybody here science nerd enough to know the symbol that we use for change in? It's a triangle, although we don't call it a triangle. We actually give it its Greek letter name, begins with the letter D. Okay. Delta V over delta T. This is still technically wrong. What I've just written is a change in speed over a change in time. Velocity is a vector, and I'm going to do this more formally in another lesson, but I always introduce it right now. Vectors have a little arrow written over them like that. It used to be, Devin, a complete arrow, but over the years we've gotten sloppy, and so we just do kind of a half arrow. So now that's a velocity. That's a speed. That's a velocity. Speed, velocity. Time is a scalar. That's the opposite of a vector. Time does not have a vector sign on it. And if I lost you there, don't freak out, Cam. I'm going to do this in a lesson properly later on, but I always show it now. There's a third thing. Time is always a change in, and so you're going to notice often for time, because the only way to measure time is to start and stop a stopwatch, often that's dropped. I'm going to leave it there, but you're going to notice for the rest of the year, we're almost never going to put a delta in front of the T. We just know it's there, it's assumed, and over the years we got lazy. Symbol for acceleration. A, lowercase. Although technically acceleration, Riley, is also a vector, so I'll do that, but I won't be too fussy. By the way, there will be a few times when I'm fussy on the notation. Most of the time, if you botch the notation, I won't take marks off, but what I'll try and do is I'll use it, Amy, as a way to remind us in our notes of what's going on. So you're going to see every so often I'm going to say, hey, you'll notice I'm paying way more attention to the vector notation here. I bet you there's a change in direction coming up and I need to freak out a little bit. So, velocity has the same symbol as speed, which is V for velocity, V for speed, although technically velocity has a vector symbol over it. If the velocity at the start of the time interval is V0, or if you're British, V0. I had a British physics teacher, so every once in a while you'll hear me say V0 instead of V0, because it sounds nerdier, and that's my little homage to him. And at the end of the time interval, it's VF, V final. Then the change in velocity will be final minus initial. If time at the beginning of this sounds really complicated, don't freak out, is time 0, and time at the end of the interval is TF, then the change in time is T. Okay, you know what? Here's what we can say then. We can say acceleration is change in velocity over change in time, final minus initial, divided by final minus initial, where the delta symbol is the shorthand for change in or interval. Little note, by the way, change in anything is always final minus initial. Before you turn the page, usually I will write this equation as A equals VF minus VI over T. Usually. And you can see already, Cade, I've gotten sloppy. I've said time is always a change in, and we get so sick and tired of writing the change in for time. We just clue in time is how long. And we have a tendency here in the BC curriculum, instead of putting a 0 there, to use an I for initial and an F for final. I think on your formula sheets, I used I for initial and F for final. Can I steal that for 1 second? Got it on there somewhere under acceleration. Oh, no, okay, I just wrote delta V over delta T, and I didn't spread it out. Okay. Now you can turn the page. What this means, Thomas, my friend, is since velocity has two aspects to it, speed and direction, acceleration can occur in two ways, Amy. If your speed changes, which is the most common one, or if your direction changes, or both change. In Physics 11, we almost always just look at situation A, speed changing. Physics 12, we do an entire unit where your speed doesn't change, but your direction changes. It's when you're moving in a circle at a constant speed. Your direction is changing because you're having to turn the corner all the time. So, you ready? A runner, example 1, our first Physics 11 question. A runner racing in a 100-meter dash accelerates from rest to a speed of 9 meters per second in 4.5 seconds. What's his average acceleration during this time interval? In Physics 11 Madison, I want to give you two main tools, two main approaches. And the first one that I use is called DFIC, DFIC. When in doubt, DFIC. When you come to a new question and you don't know what to do, Noah, DFIC. And eventually you'll get good and you'll skip this. The word DFIC, it's an acronym, and it stands for list your data, find a formula, insert the numbers, and calculate the answer, crunch the numbers. I'm big on that because it gets rid of the whole, Thomas, my question's blank, I don't know how to start. I have learned over the years, if I can get you guys writing, your brain works better when your hand is moving. Don't blame me, trust me. So you ready? We're going to defic. We're going to list our data. We're going to read through this question, and anytime we see a number or a physics word, we're going to write down what it is. So starting at the beginning, what's the first number you run into? What is that? Look at the units next to it. What are the units next to it? So is that, hey, what is that? Out of what I've said so far, that's a distance. Then there's a physics word that you're going to get in the habit of underlining physically or mentally all the time, and it's this one here, from rest. Can you underline the phrase from rest? We'll come back to that in a second. I see a 9. See it? What's that? What are the units next to the 9? Meters per second. Is that an acceleration? Is that a time? What is that? It's a speed? Initial speed or final speed? Read the question. Final? You're right. How do you know? Okay, and this it's tough for me to explain in English, Thomas. All I can read the question, whichever one is what you end up at. So you know what? Let's put a little F there for V final. Did they tell me the initial speed? They did, but they didn't tell me it as a number. They told me it in English with words. What is my initial speed? 0. How do you know? Okay, trust me, that phrase from rest, you're going to want to keep an eye out for all the time, Amelia. I'm going to use that fairly often. So, keep reading, keep reading, keep reading. Oh, 4.5, what's that? What are the units next to it? Seconds. Oh, what is that? Technically a change in time. As of right now, I'm telling you, I'm no longer, don't write this down, I'm no longer going to do that. I'm just going to do that. What do they want me to find in this question? Acceleration. So I'm going to write, what's our symbol for acceleration? What did we say? I'm going to go A equals question mark. That's my shorthand for this is what they're asking me to find. Now, why do I do this? Hopefully, first of all, hopefully I'm giving you, Kyle, a nice systematic approach to list everything. And did you notice a lot of the time I figured out what something was not by looking at the number, but by looking at the units? So one of the things I hate memorizing useless crap, but one of the things I'm going to teach you is memorize what units go with what particular measurements, because it cuts down on your thinking an awful lot. Okay? I wrote down what they wanted me to find in my abbreviated, put a little question mark there. Now, there's my data, formula. I'm looking for an equation that has to have an A in it, because that's what I'm trying to find, and has some of this other stuff. Now, we've only found one equation right now. I've only given you one. It's this one right here. So I'm going to write it down. A equals VF minus VI over T. By the way, you'll notice on your formula sheet the way I wrote that is like that. Can you see that this really is that? Okay. Do I know VF? Yeah, by the way, so you got a nice, quick, easy way to check? Glance, right? Do I know VI? Do I know T? What extra information did they give me that I haven't bothered using? Didn't need it. Okay? Nine minus 0 all over 4.5. Stop. In your head, Thomas, what's 9 take away 0?
9.
I picked these numbers carefully. What's 9 divided by 4.5? Anyone? 2. 2. By the way, how many sig figs? 2, right? 9.0, 2. How many sig figs? 2. Did we divide? How many sig figs should be in my answer? I won't take marks, aside from the first unit test, I won't take marks off for sig figs for the rest of the year, but I will always remind you we should technically go like that. What are the units for acceleration? Well, put your pencils down for 1 second. Once you've written the 2.0 and look up. Velocity is meters per second divided by time is seconds. So it's really meters per second, except there's a shorter way to write meters per second. I have 2 S's on the bottom. The shorter way to write it is meters per second squared. Pick your pencils up, write that down. .0 meters per second squared. Okay? What that means is every second your speed is increasing by 2 meters per second squared. The standard unit for expressing acceleration is meters per second squared. So an object accelerating at a rate of 1 meter per second squared, it's accelerating at that rate if its speed is increasing by 1 meter per second every second. Number 2. A UFO is reported as accelerating from rest. You know what? I would probably underline the word from rest because that tells me something. To 680 kilometers per hour in a time of 2 seconds. What's its acceleration? Okay. DFIC. What do they want me to find in this question? Yep. You know what? Usually I do that first, actually, because if I can't figure out what they want me to find, then it doesn't do me any good to start. Now, let's read through here and list my data. From rest, what's that telling me? VI is 0. 680, what's that? Hint, look at the units. V5 is correct. V5. Two. What's that? Looking for an equation that has A, VI, VF, and T in it. Well, you only got one right now. Right now, all we have is A equals VF minus VI over T. By the way, the reason this one doesn't show up on your formula sheet, it does show up on your formula sheet in disguise, but we have a different version that we go to. Where VF is 680, VI is 0, T is 2. I could probably tolerate going to your count. Well, no, it's 680 divided by 2. I think I can do that in my head. What's 6 divided? Yeah, 340. Now, these ones here, this here, Jordan, has some strange units because the top is kilometers per hour and the bottom is in seconds. This is also an acceleration unit, but I don't like it. I'll tolerate it. This is saying, by the way, every second this UFO is increasing its speed by 340 kilometers per hour. That's a pretty high acceleration, by the way. Okay. Later on, we'll learn how to convert that into G-forces and stuff like that, but we're not there yet. So I wrote down here, this acceleration might be written in the form 3.4 times 10 to the 2 kilometers per hour per second. Although kilometers per hour per second is not the officially accepted unit for acceleration, it's often used when describing the acceleration of an automobile. Why? Because your automobile speed is given to you often in kilometers per hour. I'm not wild about it. You're going to find 99% of the time I give you units and I say convert it to meters per second. But, okay, there it is. Next page over. Homework exercises. Stuff you can try so far. What's the average acceleration if? So you can certainly try number 1. You can try number 2. Number 3. Sure, we can figure out Usain Bolt. Number 4. Number 5 and number 6. Why did you just sign all? Well, I'm not done yet. Okay. Number 6, I haven't talked about yet. This is going into what we call G's, and I will cover that as a lesson. But you're going to find, Thomas, a lot of the time in the homework, I'll give you 1 or 2 questions that I haven't specifically talked about. I'll start out when I see you guys next, which, holy smokes, isn't going to be for a week. No, Monday, I guess. I see you Monday. I'll say, hey, questions from the homework. Feel free to ask me number 6, but I'm always curious to see who can follow the instructions and figure it out and arrive at the answer, which is why I give you the answers. Okay? And as a reference, by the way, the elevator, typically you get about 3 G's. And we'll talk about what G's are. Then we got speed. Okay, now, can I steal your formula sheet again, Oscar? Thank you, sir. So on your formula sheet, you have speed equals distance over time. I can't believe I left that an S. I should have changed that to a V. So if I'm asking you to find its average speed, you can do that. So number 1 is good. Number 2 is good. I haven't yet showed you how to go from kilometers per hour to meters per second. I'll be doing that next lesson, although we did a whole section on unit conversion. See if you can figure it out. 3 is good. Now, what are they asking you to find for number 4? Read it. What are they asking you to find for number 4? Distance equals v times t, right? So at the very beginning, on the very first page, when I gave you these, as far as I'm concerned now, Natalia, I can give you any 2 of these, find the third. Any 2 of these, find the third. Any 2 of these, find the third. So I'll give you number 4. I might end up giving you all of these because they're going to go pretty quick, I think. Yeah, 5 is good. 6 is tricky. Yeah, I'm going to skip 7. Now, I didn't give you the answers in brackets to this, but if you look, you should find your answers on the bottom here somewhere. In other words, if you get number 1, you should be able to cross out one of these answers because it should show up. When you get number 2, you should be able to cross out one of these answers because it should show up.